Alright, here's solutions to perfect problem 6 for Math 60. So we're given these two equations, these two linear equations in two variables, and asked to find solutions to each one individually by filling out these tables. So I think the easiest way to do these is, since it's the y values we need to know here, I think the easiest way to do it is to solve these equations for y. So to get the y all by itself, we could subtract 1 from both sides and get y equals 2x minus 4. So then what we can do is plug in each of these values. Maybe I'll switch colors. We could try to figure out what y equals when x equals negative 2. So I'm going to run out of room, but let's see. If x equals negative 2, we get y equals 2 times negative 2 minus 4, which is negative 4 minus 4, which is negative 8. So what I get is a negative 8 up here, somewhere up there, negative 8. And then we can keep doing that. If x equals negative 1, we'd get y equals 2 times negative 1 minus 4. This is negative 2 minus 4, so we get negative 6. Do a couple more. If x equals 0, we get y equals 2 times 0 minus 4, so you get negative 4. And by now you might be seeing a pattern, so you might skip these last couple, but I'll do them anyways just so my solutions look a little bit more complete. 2 times 1 is 2, minus 4 gives me negative 2. The pattern continues. And finally, x equals 2, we get y equals 2 times 2, which is 4. Minus 4 gives us 0, so we get a 0 there. We can do the same thing over here. Now my equation is 6x minus 2y minus 4 equals 0. So I'm trying to get the y all by itself. A couple different ways to do that. One way would be to add 2y to both sides and get 6x minus 4 equals 2y. And then if you divide everything by 2, you get y equals 3x minus 2. And then we can kind of go through those same steps we did over here. If x equals negative 2, we get 3 times negative 2 minus 2, negative 6 minus 2, which is negative 8. And if x is negative 1, get 3 times negative 1 minus 2. Negative 3 minus 2 more gives us negative 5. And I'll keep going through filling out the rest of these guys, although it's kind of tedious at this point. Let's see, if x equals 0, I'd have 3 times 0, which is 0, minus 2 is negative 2. If x equals 1, I have 3 times 1, which is 1, minus 2 is positive 1. And if x equals 2, 3 times 2 is 6, minus 2 is 4. So if I fill those in here, I have all 5 solutions for each equation. Then what I can do is go down here and plot those points. So plotting each of the points I found up here, I got when x equals negative 2, y equals negative 8. So negative 2 is right here, and negative 8, 1, 2, 3, 4, 5, 6, 7, 8. Looks like this point right here is at negative 2, negative 8. Double check that I counted right. Yep, looks good. And then if x equals negative 1, y should equal negative 6. So here's negative 1. And I go all the way down here to 6. And if x equals 0, my y value should be negative 4. 1, 2, 3, 4. And if x equals 1, y is negative 2. And finally, if x equals 2, my y value equals 0. So I get all these points. And then I can connect them with a straight line or a straight-ish line. It's a little bit hard to do on a computer. Whatever, good enough, huh? Maybe I'll make my dots a little bit bigger so I can really see where the points are. And then I can move over to this guy. So equation 2, kind of same idea. Maybe I'll use a different color. I got a point when x equals negative 2, my y is supposed to be negative 8. So here's negative 2, 1, 2, 3, 4, 5, 6, 7, 8. Make a point right there. And when x equals negative 1, y equals negative 5. 1, 2, 3, 4, 5. Right there. Yeah, that looks right. And then if x equals 0, my y is negative 2. If x equals 1, my y is 1. And if x equals 2, my y is 4. 1, 2, 3, 4. Something like that. And I'll try my best to connect those with the straight line. Although, again, it's a little bit hard to do on a computer. Something like that. And I think that's everything. We figured out 5 specific solutions for each one. But then these lines are supposed to represent all of the solutions. So that is the end of this perfect problem.